Okay, now two objects are connected by a light string that passes over a frictionless pulley. Remember, the pulley must be frictionless, yeah? Because we haven't entered the later chapter which involve the pulley also inside the calculation. Okay, that is a chapter rotation of rigid body. That one involve the pulley. Right now we don't involve the pulley. We just say the pulley is frictionless. Frictionless. Okay. Okay, as in the figure, the coefficient of kinetic friction of the plane is 0.3. Oh, now he give the mu. That means this plane is rough. It's a rough surface. It has friction. Okay, it has friction. So this one kinetic friction. So this is what we can say. This is kinetic. So this is just coefficient. You see, no unit also. 0.3 has no unit, so it's not friction. It's just a coefficient. It's just a mu. It's just a mu k. Okay, it's just a mu k. Now, and mass 1, mass 2, and the angle 55 degree. Okay, sketch a free body diagram for both objects. So, okay, we want to draw the free body diagram. Okay. First of all, okay, let's do the question A first. Let's draw the free body diagram, FBD. Again, what I want to say again and again is, here you have how many objects? Two objects, mass 1 and mass 2. So if you have two objects, that means you need two free body diagram. You need two free body diagram separately. Yeah, mass 1, one free body diagram, mass 2, another free body diagram. Okay, so okay, before that we need to identify what kind of forces exist for mass 1 or mass 2. Okay, look at mass 1. So what force exists on mass 1? Okay, just draw roughly. Mass 1, it has the weight. Okay, it has the weight, weight 1. It has a tension in the string. Okay, tension in the string. I think that's it. Yeah. No more other forces, right? That's it. Yeah. And then it's not in contact with the surface also. Yeah. No normal force. Yeah. Okay. And then did he say got acceleration? Oh, this he say these objects accelerate. You see that? Accelerate. But we don't know it accelerate. We don't know which is bigger, right? Did he say which one is bigger? He said mass 1 is only. Do we say a mass? Okay, maybe you predict that mass 1 falling, going downward, mass 2 going up. Is that what you predicted? Is that what you predicted? Mass 1 going down, mass 2 going up, because mass 1 is vertical. Because mass 1 is vertical. So you think this is heavier and mass 2 is lighter, but you see that do you see the mass? Do you see the mass? Actually, mass 1 is a small mass. We can imagine this is just a very small mass, but this mass 2 is actually a big mass. It's actually a big mass. Yeah. So which direction should it fall? Maybe it fall in the opposite direction, not the way you think. Maybe it fall this one being dragged up and mass 2 being dragged down, because mass 2 is actually 6 kilogram compared to mass 1 only 2 kilogram. So okay, maybe I should write over here. Mass 1 is only 2 times gravity, but mass 2 is okay, the weight 2, this one is 6 gravity. Whoa, mass 2 is much heavier compared to mass 1, isn't it? So which direction should it fall? Is it mass 1 fall down because it's vertical? Yeah, because it's vertical, so it fall down, and then mass 2 being dragged up, yeah, because it's on an inclined plane. But the other prediction is mass 2 is actually a much bigger block compared to mass 1. Mass 1 is just 2 kilogram. Mass 2 is 6 kilogram. So this mass 2 seems like much heavier compared to, is 3 times heavier than mass 1. So maybe mass 1 not fall down, it should actually go up, because mass 2 is much heavier. It drag this one, mass 2, much heavier, it should actually fall down, and dragging mass 1 up. So maybe it's actually the black direction, not the red direction. So which way? Should mass 1 go down or should mass 1 go up? Which one? So how do we know about this? So there are things we need to investigate first before we jump into conclusion. Okay, how do we draw the acceleration? Should we draw the acceleration for mass 1 downward, or acceleration mass 1 upward? Which direction should we draw to be accurate? What we should do is, first of all, look at the angle 55 degree. This angle is, look at this angle, this is 55 degree. Understand? So what you should do is, let me delete everything over here first. Okay, this is 55 degree. What you should do is, to know that mass 1 go down or mass 1 go up, you need to investigate first two forces. Okay, no, first of all, you identify all forces first. Yeah, you don't know the direction of acceleration. First you investigate all the forces first. Yeah, investigate all the forces. So okay, just now we already got the weight. Yeah, mass 1 is here I have weight 1, which is 2g, and it has the tension. Okay, don't bother about the acceleration first. Go up or go down, we don't bother first. Okay, find out what forces have in the block first. Yeah, now mass 2, it has what? It has the weight. Which is 6g, and then it has the tension, okay, being pulled up. Okay, tension always, tension always away from object. Yeah, tension always away from mass 1, away from mass 2. I did mention this on the concept video already. Yeah, now mass 2 also have this normal force because it is in contact with the rough surface, so this is the normal force 2. And then what else? Okay, friction. He did say got friction, isn't it? This surface is rough. Okay, we write it as rough surface. So friction, there is a frictional force, but we don't know the direction of friction is go up or go down, because we also don't know the direction of motion. Is the mass 2 go up? Is it going up? Or is the mass 2 going down? We're not sure, isn't it? So we not sure the direction of motion. We don't know the friction should, if the acceleration is going up, that means friction should actually go down. Friction. But if the acceleration is go down, friction should go up. So we don't know the direction of friction also is a problem. So what do we do now? What is the first step we do? We don't know the acceleration direction, so we cannot draw the friction. So what we do now is compare these two forces. I want you to look at, compare these two forces. Compare this one, weight 1, and compare this component. These two opposite components. See which one is bigger. Compare this one and also this one. Okay? Okay. Now, these are the two forces we need to compare. See which one bigger. Is this weight 1 bigger, or is this component, which is the direction of motion is this way. Yeah, we don't know is going up or going down. Yeah, is this way. The velocity is this way. So these are the two components we need to. These are the two forces that determine whether which block go up or go down. So the first force is this one, weight 1, and the other force is this one. Is this one. So what is this force? What is this force? This is not friction. Okay, this force is actually the component of weight 2. Or we can say the x component. The x component of weight 2. Okay. Let me write it down for you in a better way. Okay. So maybe we should make it bigger. Yeah. This is the weight 2. This is the weight 2. Okay. This is the weight 2. And we need to find the x component, of weight 2, which is okay, I draw first. Okay, we need to find the x component of weight 2. Okay, first of all, we draw the axis, x and y axis. Okay, to find the x component of weight 2, we need to resolve weight 2. Resolve weight 2 into x and y component. So to resolve that, we need angles. Okay, we need angles. Still remember when this you see here, this angle is 55 degree. 55 degree. I did mention in the earlier video, when this angle theta, when this is the angle theta 55 degree, this angle here also 55. Look up my previous earlier video. I already explained why when this is angle theta, this one also angle theta. When this is 55, this one also angle 55. Okay, look at go and search out my earliest video. Yeah, so this is angle theta here, 55 degree. So to find the x component, it is actually okay, the x component. Okay, we want to find the x component. X component. This is the x component. Okay. Okay. So this x component is what is how to cosine or sine theta. This component is actually opposite the angle. Do you see that? This is the you see this one. Okay, look at here. Okay, now look at this. So this x component of weight 2 should be opposite the angle, right? Opposite the 55 degree. So this x component should use sine theta. It is weight 2 sine 55. Weight 2 sine 55. Okay, so this is what we need to compare. We need to use this one, this component, weight 2 sine 55, to compare with weight 1. See which one is bigger. So if weight 1 is we calculated is bigger than weight 2, that means it should, that means this one should that means this one, okay, that means if weight 1 is bigger than weight 2 sine 55, then this one should fall down and this one should go up. Okay, but if W2 sine 55 is bigger than weight 1, okay, then the opposite will happen. The mass 2 will fall down and mass 1 will go up. You get the sense, the common sense that I'm trying to say here. Just compare these two forces. The forces, these two opposite forces. See which opposite force is bigger. See which force is bigger, then we can see the resultant force in which direction. Okay. So let's calculate. Let us calculate first. Yeah. Let us calculate what is weight 1. Weight 1 is m1g, which is just the 2 kilogram. So it is 2 gravity. So let's calculate what is the answer for this one. 2 times 9.81, which is 19.62 Newton. 19.62 Newton. Now how about the W2 sine 55? W2 sine 55. Okay. It is W2 is actually M2G sine 55. Okay. M2G. We not compare weight 1 and weight 2 only. We not compare weight 1 and weight 2 only. We compare weight 1 and weight 2 sine 55. Because you've compared with weight 2, not accurate. It is weight 2 sine 55, which is dragging it downward, dragging the mass 1 up. Understand or not? It's not the weight 2. It is the weight 2 sine 55 that is pulling mass 1 up. Okay, it's not the weight 2. It's the weight 2 sine 55 only. Yeah, weight 2 sine 55. That's why you compare weight 1 with weight 2 sine 55 only. Yeah, not with weight 2. Okay? So okay, let's calculate the weight 2 sine 55. So I got mass, okay, the mass 2 is a 6 kilogram. So it is a 6g sine 55. So what is the answer? So for this, the answer is, oh, I got the answer is this one is 48.215 48.215 Newton. Oh, so from here we can see that which one bigger? Which one bigger? So from here we can see that the weight 1 is smaller compared to weight 2 sine 55 because weight 1 is only 19.62, but the weight 2 sine 55 is 48.215 Newton. Yeah, this one is 19 Newton, this one is 48 Newton. So this one is much bigger. So we can see conclusion is mass 1, okay, so it should go which direction? The mass 2 fall down, mass 1 go up. Yeah, so we can say the mass 1 rises. Yeah, mass 1 rises and mass 2 falls. So mass 2 falls, mass 1 rises. It's not the mass 1 fall. Just now I thought that, oh, mass 1 is vertical, so vertical should fall. The mass 2 not totally vertical, it should go up. Wrong. Yeah, wrong prediction. We should always compare first. Compare the weight 1 with the x component of weight 2. So I got this x component is actually much bigger compared to weight 1. So this one should actually fall. Yeah, this one actually go up. Okay. So this is the thing. Yeah, remember this. Now we got already. Yeah, we got everything ready. Now we can know. Okay, so this mass 1 is going up, rises. Mass 1 rises. Mass 2 falls. Okay, mass 2 falls. So this acceleration direction is correct already. Yeah, this acceleration go up, this acceleration go down. Now we can know the direction of friction. Because this surface is rough. Now we already know the definite direction of motion. The direction of motion is mass 2 slides down. Mass 2 slides down. So the mass 2 slides down, friction should go up. Friction should go up. Friction should go up. This is the friction. You see that? So first of all, we need to know what is the direction of acceleration first. Once we know the direction of acceleration, then only we can figure out where is the friction. We can figure out the direction of friction after we know the direction of motion. So friction is go up. Okay, so what other forces you have? I think all complete. Mass 1 is tension and weight. Mass 2 is the normal force, tension, friction, the weight. Yeah, I think that's it. All the forces already complete. Now draw the free body diagram. Okay, draw the free body diagram. Okay, draw the free body diagram. Come on. Part A. Yeah, we haven't even started part A yet. Okay. Okay, so part A, let's draw the free body diagram. Okay, two objects have two free body diagram. So we have one for mass 1 and then another for mass 2. mass 1 is 2 kilogram, and mass 2 is 6 kilogram. Okay, now two separate free body diagram. So okay, hold on a second. Okay, now draw the x and y axis. Okay, so we have the x axis, we have the y axis, and same thing goes to the but the thing is, for mass 2, just think of mass 1 first. Mass 1, okay, draw the point mass first. So this is the point mass. So we have the weight 1 going down. Yeah, weight 1 going down. And then we have tension going up, and that's it. Yeah, tension going up. Acceleration go up. Acceleration go up, not go down. This is the prediction we got from the earliest calculation. Okay, acceleration, this mass 1 rises, mass 1 rises, so acceleration go up. Okay, so that's it. Yeah, that's it. Yeah, so we already got the x and y axis. This is the x and y axis. Okay, that's it. And then for mass 2 is okay, you see this one on inclined surface, so the x and y axis need to be tilted. The x-axis need to be parallel to the surface. Okay, so please, so I write, draw the x-axis is tilted. Okay, this is the x-axis parallel to the surface. Okay, draw it smaller. Okay, x-axis, and then this is the y-axis. Okay, I need to be a good artist for this. This is the y-axis. So this is the y-axis that's tilted. Don't make it don't correct it. Don't correct it become horizontal. That's not accepted. Yeah, the answer scheme don't accept the corrected axis. You must draw it. If the surface is inclined, your axis must be inclined. Okay, so okay, draw the point mass only, don't draw the block. Okay, and then it has the weight. Okay, this is the weight, W2, and then it has the normal force. It has the normal force 2, and then it has the tension. Okay, and it has the friction. Because this block is going down, so friction is going up. This way. This is the direction of friction. This is the kinetic friction. Okay, so we got okay, and then acceleration is going down. Acceleration going is going this way. Acceleration going down. Okay, so now don't forget, you need to write the angles also. This is 55 degree. Okay, this is 55 degree. We got the angle here, 55 degree. Okay, all right, this is the angle, 55 degree. Okay, that's it. Yeah, okay, that's the free body diagram. Complete free body diagram for mass 1 and mass 2. All right, I think that's correct. Yeah, so normal force, friction, tension, and the weight. Yeah, that's correct already. Now the next is find the acceleration of the objects. So what do we do now? Okay, so we need to do, there's several things you need to do. Quite a lot of things to do. Okay, let me do it. Yeah, okay, so for you look at this one. For mass 1, it only has y components, so you only do for y components. But for mass 2, it has 2 components. You have a x component and also the y components. You have 2 components. Okay, so now first of all we do the y components, right? Okay, now right, okay, so now okay, we need to draw the we already got the free body diagram, so we need to build the equations for this free body diagram. Yeah, so for mass 1, it has only y components. Okay, y components. And okay, remember what we learned earlier? Okay, maybe I should put this again. All right, here, hold on a second. Okay, put it over here. Yeah, sorry. Where is the diagram? Yeah. Yeah, just put it over here. Yeah, I don't know what happened. Yeah, 1 second. Okay, now look at here. Yeah. So for y component, this one got acceleration, isn't it? Got y acceleration. So it is not equilibrium. So total Fy equal to MA. So this is M1A, yeah, for mass 1 only. So which one is positive? Which force is positive? Tension or weight? Still remember this one? When you have F equal to MA, acceleration, Newton's second law. When you have acceleration, so then you need to compare with acceleration. Compare with acceleration. So follow acceleration, positive. Okay, follow acceleration, positive. Opposite acceleration, negative force. Okay, so we can say acceleration is going up. Acceleration going up, so the forces upwards should be positive, and the force that opposite the acceleration, like going downward, should put negative. So we see the tension is same direction with the acceleration, so this tension should be positive. So put as positive tension, and this weight is opposite the acceleration, isn't it? Opposite the acceleration, so it's a negative force. Always compare with acceleration if got acceleration. Okay, so okay, that minus weight 1 equal to M1A. Then we can further derive this. Mass 1, this weight 1 is actually M1G with M1G. M1, okay, M1 is 2 kilograms, so it's 2G. So it is 2G equal to this mass 1 is 2. Okay, so we got one equation already. From here, we've got tension and acceleration here, unknown. Now we have two unknowns here. We need to do another equation to solve it. Yeah. So here we need another equation. So let's do it. Yeah. So here also we need to make a boundary. Yeah, because two separate things to do. Okay, so let's do for the for mass 2. Mass 2, we have two components. We have x and y components. We need to consider, this time we need to consider the y component. We need to do the y component. Why? Because we have friction. Because now we have friction, because coefficient mu is given. So we knew that friction is equal to mu kn, isn't it? Friction equal to mu kn. So the x component now has friction, which need to find the normal force. Okay, need to find the normal force. The normal force only can be gotten from the y component. You see that the normal force is in the y component. So you need to get from y component. So you need to do the y component this time. Okay, let me show you how. First of all, before we build the equation, we need to resolve this weight into x and y component, because all the other force already on the x and y axis. Only the weight is not on the axis. So it has two components. It has the x component and also y component. Just now also we already got the x component of weight, which is W2 sine 55, isn't it? So this time just do the same thing again. Yeah. So weight 2, it has two components. Let us derive it out. Weight 2, it has two components. So it has this one and this one, x component and y component. So the x component, yeah. So again, it has the x component and y component. So the x component, look at the y component first. Y components is adjacent to 55, isn't it? It is adjacent to 55 degree, so it is a cosine theta. So this one we put as W2 cosine 55. Okay, why cosine? Because adjacent to angle. And then this one, this is the y component. Y component use cosine 55. How about the x component? X component also just now we got sine 55, isn't it? X component is opposite to the angle. Yeah, x component is opposite to the angle, so it's sine 55. So it's W2 sine 55. We got it. Okay. So now all the forces already in the x and y axis. Now it's time for us to build equations. So for x component, look at the x-axis. X component, we have acceleration. That's why we need to draw the acceleration. Why we need to draw the acceleration beside the free body diagram? So that we can know which component, which x or y component has acceleration. If have acceleration, we need to compare with acceleration to know whether the force is positive or negative force. So acceleration is so important, yeah, and also to know whether it is equilibrium or not equilibrium, yeah. Like for this one, you draw acceleration at the x component. That means we know that in the x component, the total fx equal to ma. Total fx equal to ma. So it's total fx equal to m2a. But the y component, no acceleration, isn't it? Acceleration only in x. Y component no acceleration. So y component is fy equal to 0. That's why drawing acceleration beside the free body diagram is very important. So for us to build equation f equal to ma or f equal to 0, understand? And also to know which one is positive force, which one is negative force. Like you see this x component, which one should be positive? Going down or going up? Should be positive. Going down the plane positive or going up the plane positive? If got acceleration, we compare with acceleration. Follow acceleration positive, opposite acceleration negative. So like this one, acceleration is down the plane. Acceleration is down the plane. So that means forces down the plane is positive. Put that as forces down the plane is positive. Follow acceleration is positive. So W2 sine 55 should be positive. Whereas this one, the tension and the friction, they are opposite the acceleration. Opposite acceleration should put negative. Understand? Okay? You understand now? So this weight W, follow acceleration positive, opposite acceleration negative. Down the plane is positive because acceleration down the plane. Going up the plane is opposite the acceleration. Opposite acceleration should put negative. Okay, so we see that W2 sine 55 is positive. So write it down. That one is positive. W2 sine 55 is positive. Whereas the tension and the friction, they are going up the plane, opposite the acceleration. So these two, tension and friction, should put negative. Put negative tension and also negative friction. Okay. So in x component only has these three force: W2 sine 55 and tension and friction. Only these three force. Okay. And then equal to the mass 2 is 6 kilograms. So this one put 6a. Okay. Now continue. Weight 2 is actually 6 times gravity, isn't it? Because okay, maybe I drag all this down a little bit. Yeah, drag all this down a little bit. Yeah, this one also just drag a little bit down a little bit. Okay. So now good. Yeah, weight 2 is 6g. So this one should be, you should put 6g. Yeah, weight 2 is 6. Write it down, 6g, then times sine 55 degree, and then minus tension minus friction. Oh, friction now. Friction is mu kn. Mu kn. I don't have the n. So that one, the n, I need to do y component first. So I cannot continue from here. I cannot continue here because I don't have the friction. I don't have the normal force. I must do y component first to find the normal force first. To find the normal force already, then I can get friction. I can substitute to here. Okay, so I need to do y component to find the normal force. Okay, So this one I cannot continue. I must do for y component. So y component has the normal force. Okay. Okay. So this one is friction. So we can put this is normal force 2. Yeah. Friction is normal force 2. What is this? Okay. So okay, let's do y component. Y component has no acceleration. Yeah, that's why equal to 0. Total force equal to 0. So in y component we have two force. We have the normal force N2. We have the weight 2 cos 55. Don't always think that, oh, normal force easy lah, normal force is equal to mg lah straight away. Wrong. Yeah, normal force is not mg. Yeah, we always think that, oh, easy, mu kn, so n is always equal to mg. So mu k how do you write? N2 you just put mg. Because n is always equal to mg. Wrong. This is wrong. This is wrong. Let me show you why n is not equal to mg. N is only equal to mg if it is on a horizontal surface. Or horizontal surface, you have mg, you have normal. Yes, this one n equal to mg. This one n equal to mg. Okay, but this case, this is inclined surface. Inclined surface, okay. Inclined surface n not equal to mg. For inclined surface n not equal to mg. Let me show you. N is what? Let me show you. So in y component, okay, is total force equal to 0. So we just take force going up is positive. Okay, we no acceleration to compare. No acceleration to compare. We just take forces going up is positive, going down is negative. That's all. Or you want to put forces going down positive, going up positive, going up negative also can. Yeah, because we know that we take n2 minus w2 cos 55 is the same as w2 cos 55 minus n. Both also you get 0. So it's the same thing. You want to use which one minus which one, you still get 0. Okay. So right now I just want to make it simple. We just take no acceleration to compare, isn't it? For y component. Y component no acceleration to compare. We just take force going up positive, force going down negative. That's it. So normal force 2 is positive. Okay, just put that. Normal force 2 is positive. And then going down is negative. Negative W2 cos 55. Negative, W2 cos 55. Okay. And equal to 0. That's it. So you want to use N2 minus W2, or you want to use W2 minus N2. Both can, yeah, both accepted, because all equal to 0. So no matter which one minus which one, also accepted, yeah, because if no acceleration, easy, yeah, which one minus which one, no problem. See this? Okay, now this one W2 cos 55, go forward. What do you get? Normal force 2 equal to W2 cos 55, which is M2G cos 55. Do you see that? This n is not mg. This n is not mg for inclined surface. For inclined surface. N equal to mg for horizontal surface only. Horizontal surface only. Understand? So n is not mg. N is equal to mg. N is equal to mg only for horizontal surface. So put it down here. Yeah. N equal to mg only for horizontal surface. But for inclined surface, n is not mg. N is mg cos 55. We have cos 55. So it's not mg. Don't directly put mg all the way for normal force. Don't. Okay. So now let's okay. So just rub this off. Now okay. Also rub this off. Now we want to calculate the friction. Now let's calculate the friction. Let's find out the normal force first. The normal force equal to the mass 2 is what? The mass 2 is 6 kilograms. 6 kilograms is so 6 times gravity cos 55. Okay. 6 times gravity cos 55. So So it is okay, let's calculate the answer for this one. Yeah. Okay, so now we this one 6g cos 55 is n2, so just substitute into here, find the friction first. So friction is just now we got the mu k already. Yeah, mu k given is 0.3 here, 0.3. This is mu k. Mu k has no unit. Yeah, no unit. So this is 0.3. Okay, 0.3. Just multiply and then multiply by the normal force. Normal force is 6g cos 55. 6g cos 55. And what answer do we get? Yeah, what answer do we get? Okay, multiply by 0.3. I got the answer is friction is 1282 Newton. This is the friction 10.1282. Okay, that's the friction. So now we got the friction already, because we do the y component, we got the normal force, and to find friction, now we can do this x component already. Yeah, we can do x component. So let's substitute the 10.1282 into here. 10.1282 into here already. Then this one equal to 6a. All right, sorry, yeah, something this one yeah, this one go a little bit here. Okay, nicer. Yeah, 10.1282 equal to 6a. Okay, let's continue. Yeah, let's continue our work. Now here we have another two unknowns. You see that? So we have t acceleration, tension, acceleration. Once we solve these two equations, we can find the tension and acceleration for our objects. We got the acceleration and tension for both answer B and C. Let's calculate now. Let's calculate. Okay, so let's calculate. So that is okay. I need to rearrange. I think I need to solve this first. Yeah, make it easier first. So let's calculate. Yeah, let's calculate. Okay, I got the answer is okay, minus, I got 30, sorry, I got 38.087087 minus tension. That means I take this 6g sine 55, I minus with 10.1282, I got 38.0871. Okay, and then I still have the negative tension, and then equal to 6a. So now I have two equations. I can you know, to find the two unknowns. I have two equations to find two unknowns. I have you see, so this is equation 1 and this is equation 2. So here I have tension and here I have negative tension. So I just plus it off. I just total it up. 1 plus 2 to get what? 1 plus 2, I get what? So the tension and negative tension cancel off. They cancel off, isn't it? Cancel off. And so what is the so it becomes what? It becomes 38.0871, and then I still have the negative 2g, and then 2a plus 6a become 8a. 8a. So I can find my acceleration already. So what's the answer? Let's calculate. I got the answer. I got the answer is acceleration is 2.31. 2.31. That's correct. Meter per second square. Is that correct? Is the answer correct? Acceleration? Yeah, is the answer correct? Acceleration? Yes, I got 2.31. 2.31. Bravo, I got the answer correct. 2.31. Okay, that's correct. Now let's find out the tension. Let's find out the tension. This is for question B. I got it. Question B. Now question C. question C, I look back to equation 1. Okay, look back to equation 1. I use the tension minus 2G equal to 2A. So A, I substitute with 2.31. So I can get my tension equal to, okay, yeah, this is a tension minus 2G. Okay, so now calculate. Let's calculate. I got the answer is answer is tension is 24.24 Newton. That's the answer. The tension 24.24. Is that correct? Yes, 2424 Newton. That's the tension in the string. Tension in the string. Yeah, tension in the string. That means tension for mass 1 and tension for mass 2. Both of them, they are 24.24. This one also 24.24 Newton. Okay. Both of them have equal tension. Okay, is that correct? 24.24. 24.24. Yes, that's correct. 24.24. So that's it for to find the acceleration and tension, and to find there's actually a shortcut to find the acceleration if you know. Okay, I taught you already. If you just want to find the acceleration, that's very easy shortcut. You know, this one total F, you just put total Fx equal to m total A. Okay, but the thing is, now you have friction. Now you have friction, so a little bit difficult. So now you have friction, so you have this one W2 sine 55 positive, but the friction and the weight become negative. So it becomes like weight 2 sine 55 minus the friction, you know, and then minus the weight 1. Okay, tension cancel off, tension cancel off, and minus the weight 1. Okay, minus weight 1, and then mass total is the mass 1 plus mass 2. Mass 1 plus mass 2. Okay, so okay, maybe we can try and see the shortcut. Yeah. Okay, so weight 2 is what? Weight 2 is 6G. Yeah, weight 2 is 6. Weight 2 is 6G. So put 6G. Weight 2 and then 6G sine 55. And then the friction, okay, friction, so we need to do the y component. Yeah, friction, we need to do the y component. We got 10.1282. Okay, let's put it 10.1282, and then weight 1 is 2G here, 2G, and then this is the whole mass is 2 kilogram, 2 kilogram plus 6 kilogram. So is 2 plus 6 here. So acceleration. So what's the answer for acceleration? Let's calculate. Okay, now I got the answer is acceleration is 2.31 meter per second square. So is it the same? Is it the same as before? Acceleration? Yes, it's the same. The shortcut is the same. 2.31 also. So it's correct. Yeah. All right, so why is this again, why is this positive? Why is this positive? And why is this negative? Why is this negative? Because this one we can see follow the acceleration. The W2 sine 55 follow acceleration because it follow okay, maybe I should write it down over here, because this one follow acceleration. And this one negative because friction and weight 1, they are negative because friction is opposite the acceleration. The weight 1 also opposite the acceleration. That's why they're negative, because they opposite the acceleration. Okay, so that's it for these questions. I hope you understand. Okay, I hope you understand the shortcuts. Yeah, and that's all for this chapter. All right, bye.